Okay, guys, today we're going to be talking about the basics of the dreaded F word of math. Dun, dun, dun. Fractions. So on the board, you can see that I have them set in two columns or sections. Some of them are proper fractions. That does not mean that they're going to curtsy as they come into the room or that they have a British accent. They are just to where the numerator is smaller than the denominator. That's why they're considered proper fractions. And then over here we have improper fractions. Again, that doesn't mean they're going to come in with ripped up genes or anything else. It just means that the numerator is larger than the denominator. So we're going to look at these and determine if these fractions are in simplest form, which means that they cannot be made any smaller because we've done all the reductions that we can do. And then we're also going to talk about how to change these improper fractions into mixed numbers. So the first thing we're going to look at here is 2/3. 2/3 is already in simplest form because both 2 and 3 are prime numbers. We're going to talk about prime numbers in another video in just a little bit. But prime numbers are any numbers that only have, so like 2 can only be gotten by doing 1 times 2. 3 can only be gotten by doing 1 times 3. Those are considered prime numbers. So we know that guy is in simplest form. It is a positive proper fraction because it doesn't have a negative symbol assigned to either the numerator or the denominator or in line with it. If both the numerator and the denominator were negative, it actually could be simplified just to be a positive fraction again, because when we're doing division and all the fraction bar is a division symbol, if we have two negatives, we equal a positive. So -4/6. This is an example of where the negative is in line with the fraction bar. This could also be written as -4/6 and have the same quotient. And then this could also be written as 4/-6, or it could be written the way I originally had it, with the negative sign in line with the fraction bar. So since both of these are even, it's a good indication that it is not in simplest form. Then we can start and divide by 2 and divide by 2, and we get that this is equivalent to -2/3. And again, I've just hopped that negative sign up with my 2. I could put it either with my 2 in line with the fraction bar or with the denominator. If I put it with both, it turns it into a positive fraction. So 4 is not prime because 4 can be gotten by doing 2 times 2, but 5 is prime. It can only be gotten by doing 1 times 5. None of these factors are in common, so this one is also in simplest form. So this guy right here could be written again. I could put that negative sign down there with the 10. Here I could change this and put the negative sign in line with the fraction. This is probably the most common way you'll see it written in a math textbook. But so you need to know that in that case, you can either make the numerator negative or the denominator negative, and you still have a negative fraction. But if you make both negative, you end up changing it to a positive fraction. So again, this guy, both of these are even numbers, so I'm going to start and divide by 2 and divide by 2, and I'm going to get it to be 4/5. And again, I'm just going to put that negative sign in line with the fraction bar. Okay? So over here, you can kind of see that I've just taken these answers and flipped them. All of these are actually called the reciprocals or multiplicative inverses of my proper fractions. So here, what I want you guys to do is just to remember again that where I can position my negative symbol, all of these are negative fractions. If I put a negative with that 2, that needs to now be simplified to just be a positive fraction if I did throw that negative in there. But again, most of the time you're going to see it like this in the textbook. So I'm going to erase these big words that I put over here and just remind you guys of how to change it from an improper fraction to a mixed number. So what I'm going to do is I'm going to do the numerator divided by the denominator. 2 goes into 3 once, and then I'm going to subtract and get 1. So this one on top becomes my whole number. This remainder becomes my numerator, and the divisor is my denominator. And since this was negative, I need to just put a negative symbol in front of the whole thing. So we're going to quickly do this one right here. -6 over positive 4. I'm just going to ignore the negatives for a second. 4 goes into 6 one time. And then I'm going to subtract and get 2. So again, whole number, numerator, denominator. It was negative, so I'm going to make sure I bring my negative over. Both of these are even numbers, so that's a great indication that it can be simplified. So it does simplify to equal -1 1/2 again. Okay, I'm just going to work this one out right below here. So I'm going to put 10 in the numerator, 8 in the denominator. Some of you guys might be saying, oh, wait, that guy can be reduced because they're both even, and you are correct. I'm just going to wait until after I change it to a mixed number to reduce it. So 8 goes into 10 one time. I'm going to subtract and get 2. So 1 gets to stay my whole number, 2 is my numerator, 8 is my denominator. I need to put a negative symbol in front of it. So this simplifies to -1 1/4, because I can divide both of those by 2. And if you guys notice, this guy and this guy, they are equivalent fractions. So this one is also equal to -1 1/4. So that's just a quick reminder of how to change improper fractions into mixed numbers and how to simplify some proper fractions and just knowing the pieces of a fraction. Numerator, denominator, simplest form just means that you can't divide either of them by any other numbers. I'm going to be right back and I'm going to review how to change mixed numbers back into improper fractions. So guys, you can see I have 4 mixed numbers on the board. We are going to take these mixed numbers and turn them back into improper fractions. Remember, improper fractions aren't fractions. They're wearing bad clothes. They just have a numerator that is larger than their denominator. That's why they're called improper fractions. So some of you guys may know the procedure for changing this is to do the denominator times the whole number and add the numerator. The reason this works is this represents, let's say we have some cake over here shaped like rectangles. Rectangles to me are easier to divide up. So we have this cake over here, and I have 2 cakes, each of which are divided into 3 sections. And then I have this last cake that was also divided into 3 sections. This one, I get all 3 pieces to represent my 2. And this one, I only get 2 pieces to represent my 2/3. So now let's count my pieces. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And they were cut up into thirds. So 2 and 2/3 equals 8/3. 3 times 2 is 6, plus 2 is 8. That's the mathematical approach. So you're going to multiply here, get that product, which is 6, and then add the 2, and that gives me my numerator. So this question, some of you guys probably are screaming that it can be simplified because you know that both the numbers are even. That is true. It can be simplified to 1 1/3. But let's draw a model of this one also. So if I have my 2 rectangle cakes, again, I draw rectangles because I feel like it's easier to get basically even sections of rectangles. If I drew it like this, this represents the simplified fraction, which is 1 1/3. But if I go back in here and split these in half, I'm now representing the non-simplified fraction, 1 2/6. But they're the same fraction. These x's were indicative of which thirds I got, so now I just have x's in each of these sixths, and it still is the same amount of cake. So if I have 1 2/6, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of cake cut into 6 sections. 6 times 1 is 6 plus 2 is 8. And the same is true for whenever I had it as the thirds. If it were my thirds, I have 1, 2, 3, 4 pieces of cake cut into 3 sections. 3 times 1 is 3 plus 1 is 4. So that's how that works with those models. So let's go over here, and these look a little bit more frightening because they have negatives in them. Really, all we do is take the absolute value of the whole number part and just use that to multiply, and we just need to remember at the end to put the negative symbol in front of the fraction again. 7 times 3 is 21. That gives me 21 pieces of cake, plus the 5 that I have is 26 over 7. So negative 26 over 7, because I put that negative symbol in line with my fraction bar. Here I'm going to do 8 times 2, which is 16, plus 5, which is 21 over 8. And again, I'm just going to put that negative sign in line with the fraction bar. If you can't remember that it goes in line with the fraction bar, you can either assign it to the numerator or you can assign it to the denominator, but you cannot assign it to both. Because if you assign it to both, it turns that fraction into a positive, and it was not originally a positive. I just always get in the habit of putting it in line with the fraction bar. Another good habit to get into is to check our answers. So to check my answer for this last one, I would just do 21 divided by 8. 8 goes into 21 twice. 16, I'm going to subtract. That gives me 5. So whole number, check. Numerator, check. And I divided by the correct denominator, check. So we know we did it correctly. So those are just some basics of improper fractions and mixed numbers. And in the next video, we're going to talk about equivalent fractions and also simplifying fractions again.